Hi everyone, this is the Math 31 applications review. This is question 15. And actually this is a classic, okay? This is one of those calculus problems that you have to do if you're in a calculus class. A 6-foot tall man walks away from a light 10 feet above the ground. Okay, so here's the scenario here, kind of drawn out. Okay, this is definitely a triangle problem. Okay, here's the 6-foot man, and here's our 10-foot lamp post. Now what that does is creates similar triangles. We've got the large right angle triangle, we've got the small right angle triangle. Okay, so anyway, if his shadow lengthens at a rate of 2 meters per second, how fast is he walking? Okay, well there's a couple of things going on here. First of all, let's call this distance right here, let's call this W. Okay, and then we'll call this right here S. Okay, for shadow. So here's W walking here. So the distance between him and the lamppost, that will be the rate at which he's walking, okay? So that's going to be dW by dt, and we don't know what that is, okay? Now, however, we do know that his shadow lengthens at a rate of 2 meters per second. So we know that ds by dt is equal to 2. Now, the relationship that we can build here, okay, is that 6 to s, and I can throw in the 6 in there into the equation that I'm building because 6 is a constant. His height doesn't change during this process here. 6 over s is going to equal 10 over w plus s. Okay, the entire bottom part here. And this is a very, very straightforward little proportion. We can use cross multiplication here to simplify this. So 6w plus 6x will equal 10s. Then I would bring the 6x over to get 6w is equal to 4s, which is a wonderful little equation to be working with. I can even simplify this further by dividing both of those by 2. So 3w is equal to 2s. And now if I take the derivative of both of those sides there, I will get 3 times dw by dt is equal to 2 times ds by dt. Now remember, I have to take the derivative of this implicitly, okay? Because they're both functions of time, except I don't see what that function is. I don't know how it's directly related to time. I just know that that exists. So w to the 1, bring down the 1, so basically taking the derivative of w is just 1, but I have to multiply by dw by dt, and the same thing for s. Now I know, okay, sorry, I should say it like this. I'm going to solve for dw by dt. That'll be 2 over 3. And we know that ds by dt is also 2. And so it turns out this is going to be 4 over 3. And assuming that the units didn't change for anything here, we're only given the 2 units here, I can assume that that is 4 over 3 meters per second.